In this video, we are going to work through some examples of analyzing the graph of a parabola. So let's start with example 1. It says, consider the graph of f of x equals a third x squared minus 3. And we see that graph on the right. Determine the values of x for which f of x equals 0, f of x is greater than 0, or f of x is less than 0. Right, now just with like the linear graphs, these questions always require you to answer in terms of x. It always asks you for the values of x. So, what you need to do is understand the question in terms of the y coordinates, find the part of the graph relative to the y coordinates, and then answer with the x coordinates. So, if we look at number 1, it says where f of x equals 0. Now we can replace f of x with y. So we want to know the x values where y is equal to 0. So take the y coordinates to find the correct part of the graph. And y is equal to 0 on the x-axis at that point and that point. Now our answer in terms of the x values. X equals negative 3 or x equals 3. Number 2, f of x is greater than 0. This means we are looking for the part of the graph where the y values are greater than 0. Now the y values are positive above the x-axis. So again, we use the y values to find the part of the graph, and we are looking at this part and this part. So two parts of the graph are above the x-axis and have positive y coordinates. Now we answer in terms of the x coordinates. So to find the x coordinates, we would draw vertical lines down. Okay, so there and there. Okay, and remember that our graph continues on. Now, if I have two parts of the graph as my answer, I will need two separate inequalities. So the first part on the left here are all the x values that are less than negative 3. So x is less than negative 3. I don't include the negative 3 because it's not also where x is equal to 0. Where f of x is equal to 0. Right, the second part of the graph are all the x values where x is greater than 3. Right, number 3 asks for the x values where f of x is less than 0. Okay, again, this is where the y values are negative. Now, y values are negative below the x-axis. So I'm looking at the part of the graph that is below the x-axis, which is this part. Okay, now I need to answer in terms of the x coordinates, so I draw vertical lines to understand where the x values are. Okay, and they range from negative 3 to 3. I don't include negative 3 and 3 because it didn't also ask where f of x was equal to 0. Okay, so if I have one part of the graph, then I will have one inequality. In this case, it's a double inequality. So my lower limit is negative 3 less than x less than my upper limit is 3. Okay, now we look at an example that has two graphs. So we are comparing graphs, okay? Right, so we have the graphs of f of x equals negative 2x minus 7. So that's the straight line. So this is f of x. And g of x equals negative x squared minus 8x minus 12. So that is the parabola. So that's g of x are drawn alongside. Determine the values of x, there it is again, for which f of x is greater than 0. Okay, so we are looking for where the y values of f are positive. So that is where the graph of f, which is the straight line, is above the x-axis. Okay, so I'm using my knowledge of the y coordinates to find the part of the graph, and this is the part of the graph of f of x that is above the x-axis. Okay, now I need to answer in terms of the x coordinates, but if we look at what we are given, we aren't given any x values. That means we need to calculate them. So what I need is the x-intercept of f of x. And we know how to calculate x-intercepts. We let y equal 0. So I have 0 equals negative 2x minus 7. And I have to solve for x. I'm going to add 7 and then divide by negative 2. So I have x equals 7 divided by negative 2, which is negative 3.5. Okay, so the value here is negative 3.5. Okay, so to answer the question, f of x is greater than 0, this part of the graph, and I need to answer in terms of the x coordinates. Okay, so these x coordinates are all values that are less than negative 3,5. So therefore x is less than negative 3,5. Okay, so for question B, let me just change the color of my pen. Okay, we are interested in the x values where g of x is less than 0. Okay, so that is where the graph of g of x is below the x-axis, because then the y values would be negative. Okay, so I use that knowledge to find the correct part of the graph. So I want the parts of the graph of g of x that are below the x-axis, so there and there. Okay, and I need to answer in terms of its x values. Okay, so two parts of the graph, but again I need the x coordinates here, which I don't have, so I need to calculate them. But their significance is that they are the x-intercepts of g of x. So to find them, I let y equal 0. So that gives me an equation 0 equals negative x squared minus 8x minus 12. And you can either use your calculator to find the speedy solution, or you can factorize. I'm going to divide through by negative 1, so I have x squared plus 8x plus 12, which factorizes neatly into x plus 6x plus 2. And if I solve for x, make each factor equal to 0, I have x equals negative 6, or x equals negative 2. So that means this value must be negative 6, that value must be negative 2. So to answer the question, the values of x for which g of x is less than 0, all the x values that are less than negative 6, so x is less than negative 6, or all the x values that are greater than negative 2. Okay, now we're going to continue with example 3. So we're working with the same graph, so the same x values that I have now calculated, but we're going to ask more questions. Okay, so I've done A, B, I'm moving on to C. So I'm just going to fill in all the values that I had already calculated. So negative 6, negative 3,5, and negative 2. Okay, now if we look at question C, okay, we're looking for the values of x where f of x times g of x is greater or equal to 0. Okay, now what we have here is a product of the y values. Okay, so product of y values. And the product of the y values in this case must be greater or equal to 0. So positive or 0. Okay. Now, what we need to do to work this out is we read from left to right. Okay, we use a vertical line, left to right, sorry. Okay, and where the product of the y coordinates will be positive, where either the y coordinates from each graph are both positive or both negative, because a positive times a positive makes a positive, and a negative times a negative makes a positive. Okay, so moving from left to right, on the straight line, the y coordinates here are all positive. Okay, it changes at the x-intercept. So below the x-axis, the y coordinates are all negative. Moving from left to right on the parabola, below the x-axis, the y values are negative. Things change at the x-intercept, because above the x-axis, y values are all positive, changes again at the x-intercept, and then I have negative y coordinates. Okay, so moving from left to right, okay, at this point here, the product is a positive times a negative, which gives me a negative product, okay? So still positive times a negative negative. Where does that change? Okay, at the x-intercept of the parabola, both the graphs are now, after the x-intercept of the parabola, both graphs are above the x-axis, which means that the product of the y values is a positive times a positive, which gives me a positive product, okay? So positive times a positive, where does that change? Again, at an x-intercept, okay? At the x-intercept of the straight line goes, after the x-intercept, the straight line goes below the x-axis. So its y values become negative. So the product then is a positive y value on the parabola times a negative y value on the straight line, which gives us a negative product, okay? So that's not what we want. But if we continue to the left, things change again at the x-intercept, okay, of the parabola. After that x-intercept, both the graphs are below the x-axis, which means both their y-coordinates are negative. So the product, negative times a negative, gives us a positive, okay? So at this point of the graph, the products are positive, and at this point of the graph, the products are positive, okay? So now, we need to answer in terms of the x values. So I'll have an inequality representing this interval. So from -6 to -3,5. And I'm going to include -6 and include -3,5 because at -6, the y value is 0, which would give me a product of 0, which it's allowed to be. Okay, and then I also need to represent this part of the graph. These are all the x values that are greater than -2. So all x is greater than -2. Do I include -2? Yes, because at -2, the y coordinate is 0, and the product of y values would be 0. Okay. Right, moving on to D, and I'm going to have to just take all my squiggles away here. Okay, so if we look at questions D and E, here we are really comparing the graphs. Okay, so I'm just writing in the, actually I won't need them. Okay, so f of x is greater than g of x. So this means where are the y values of f greater than the y values of g? In other words, where is f of x above g of x? Okay, so remember f of x was the straight line and g of x was the parabola. Okay, so moving from left to right, we start with the graph of f of x being above the graph of g of x. If it's above, it means that the y values are greater. Okay, so this part of the graph, we have f of x above g of x. Okay, but then at the point of intersection, it changes. After the point of intersection, f of x is below g of x, which is not what we want. Okay, again, at the other point of intersection, things change, and f of x is above g of x again. So the parts of the graph that we are interested in are here, okay, and it changes at the point of intersection, and this part here, these x coordinates where things have changed at the points of intersection. So we need the x values of the points of intersection. So for D, we need to do a bit of a calculation. We need to calculate the points of intersection. Okay, to calculate the points of intersection, we equate the graphs. Okay, and f of x had the equation -2x minus 7, and g of x had the equation -x squared minus 8x minus 12. Okay, so we need to solve this, write it in standard form. It's a quadratic equation, so I'm going to add x squared on both sides. That's a 2. Okay, then I'm going to add 8x, so I'm left with minus 2x plus 8x is 6x. Then I have negative 7 plus 12, which gives me positive 5 equals 0. I can now use my calculator to find the x values or factorize. It factorizes nicely, so we can do that. X plus 5, x plus 1. And making each factor equal to 0, I can solve for x. X equals negative 5 or x equals negative 1. So I know that the x value here is negative 5 and the x value there is negative 1. So to answer the question for D, I have two parts of the graph where f of x is above g of x, so I will need two inequalities in my answer. The first inequality are all the x values that are less than negative 5. So x is less than negative 5. Or the second part is where all the x values are greater than negative 1. I do not include the negative 5 or the negative 1 because it did not also include where f of x was equal to g of x. Okay, looking at E, now we are interested to know where f of x is less than g of x or equal to g of x. Now f of x is equal to g of x at the points of intersection, but f of x is less than g of x where f of x is below g of x. Okay, so it can only be below g of x where it's not above, and we've just looked at where f of x was above g of x. Okay, so at this part of the graph, f of x is below the parabola. Okay, so there's one part of the graph, so I will have one inequality. Okay, and the x values range from negative 5 to negative 1. So my answer for E will be a double inequality. So negative 5 is less than x less than negative 1. But because it also included where f of x was equal to g of x, I include the x coordinates of the points of intersection. Final example. Here we have two graphs. Okay, the parabola f of x equals a half x squared plus 4x plus 6, and the horizontal line y equals negative 2 that are drawn. It says determine the point of intersection algebraically. Now, we can graphically see what the x coordinate of the point of intersection is. Okay, so not only the x coordinate, but also the y coordinate. But it asked us to determine it algebraically, so we must do that. And we know that to calculate points of intersection, if both of our graphs are solved for y, then we can just equate the graphs. So I have a half x squared plus 4x plus 6 equal to the other graph, which is negative 2. And I can solve this for x, okay? It's a quadratic inequality, so I need to write it in standard form. So I'm going to add 2. So I have a half x squared plus 4x. 6 plus 2 is plus 8, okay? You're welcome to use your calculator, but I'm just going to show you how you could factorize this. I don't like the fraction, so I'm going to multiply every term by 2. So that gives me a coefficient of 1 to the x squared, plus multiplying this by 2, I've got 8x, plus, and then 16 equals 0. This factorizes neatly as x plus 4 times x plus 4, so that's x plus 4 squared equals 0. And I can make that each factor equal to 0, and I get x equals negative 4 or x equals negative 4. Now this is a nice example of having two equal solutions, and on the graph we see that equates to just one point of intersection. Okay. Now these are just the x coordinates. I still need to find the y coordinates, okay, of the point of intersection. So to do that, I substitute, or actually in this case, because I have a horizontal line, I can only have one y coordinate, so it's negative 2. So my point of intersection is at negative 4, negative 2. Okay. Now this is the same question, but now I've moved on to the question B. Okay. And it says give the values of m, for which a half x squared plus 4x plus 6 equals m has equal roots, 2 real roots, or non-real roots. Okay, now notice that a half x squared plus 4x plus 6 is my parabola equals m. Okay, now we have just looked at an example where we solved simultaneously to find points of intersection. So what this m represents is the equation of a horizontal line that intersects with my parabola, either to give me equal roots, 2 real roots, or non-real roots. Okay, so for equal roots, my horizontal line and the parabola would intersect just once, at one point, which would be at the turning point. Okay, that is the scenario that we have in the diagram. Okay, it intersects at one point. So in that case, it would be y equals -2 would be the equation of my horizontal line. So in that case, m is -2. So in this case, m equals -2. Now for number 2, we need to give the values of m for which these two graphs have 2 real roots, which means 2 points of intersection. Okay, now they would have 2 points of intersection anywhere above y equals -2. Could be at y equals -1. Those graphs would intersect twice. Y equals 2, we would have 2 points of intersection. Going higher, y equals 5, 2 points of intersection. Y equals 9, 2 points of intersection. So in this case, m can be any value greater than -2. Now for number 3, we want non-real roots, which means no points of intersection. Now when would that occur? That would occur where the graphs don't intersect at all. So in that case, the horizontal line must be below the turning point. So that means m can be any value less than -2.